Hey everybody, welcome to Bill Sky, the C++ guy, and this is our second video on object-oriented programming. And I'm assuming that you watched the first video. We did a whole bunch of stuff on puppies as an introduction to object-oriented programming. But in this video, what we're going to do is we're going to look at pointers. How do you use puppy pointers? How do you use class pointers or object pointers when writing your code? So let's just jump right into it. All right, so I've got the project that we created in the first video of this series, and let me just quickly go through it. We created a structure which we don't really need anymore, but I'm going to leave it there. But we also created a puppy.cpp file and a puppy.hpp file. Now, if you don't know how I did this, go back and look at video number 1, and it's not a very long video. It's only about 15-16 minutes or so, and you can find out how we did that in that video. So go ahead and take a look at that, and it goes through all of this. But just as a summary, we have a puppy class. We have a class called puppy. It has a constructor and a destructor. It has a little function that we created called print my name. It really doesn't do very much except couts the name variable. And then we created some attributes, which is what they call in object-oriented programming. Variables inside of a class are called attributes, and we created 4 of those. And then we put the implementation of the functions in the CPP file. So you can see here we've got your constructor, which is simply saying you're creating a puppy. We've got the destructor that says you're deleting the puppy, and it also includes the variable or the attribute inside of the puppy class, or the puppy object in this case. And then we have the print name function. So we're not going to be doing a whole lot with that stuff in this video, but what we are going to do is we're going to talk about, instead of creating static puppies, we're going to talk about creating puppy pointers. So if you remember, or if you look at my at previous videos in this advanced C++ set of videos or series of videos, take a look at the pointer videos. If you're not really sure about pointers, because that's what we're going to do here. But pointers of objects are exactly the same as pointers to structures or pointers to variables like integers or doubles or any native data type instead of C++. And the way that you do it is just like with those. You just put an asterisk right after the data type. Now, if I go ahead and I build this, we're going to get a bunch of errors. And the reason is because these are no longer puppy static variables. They are actually puppy pointers, and we actually haven't created the puppy yet. We just have the container to contain the address of the puppy. So there's a number of things that we haven't done here yet, and let's go ahead and do that. So now that, and one other thing I wanted to mention, you can create it like this, you can do it like this, or you can do it the way that I had it. It makes no difference, okay? People might argue and say, oh my God, you never put it right after the data type, you put it up against the variable name. Fine, you can do it that way if you want. It's just style. But also remember, it could also be part of a standard that the company you're working for requires you to do. So make sure you ask the company for a programmer's user's guide to see all the standards that they want you to do, and you really want to do it that way. So, but you know, if you're just doing it as a hobby or in class, you don't have to worry about where you put that asterisk. All right, so what are some of the first things that we have to do to get rid of these errors here? Well, we have to allocate the puppy first. So I'm going to say my first puppy is equal to a new puppy. So that's the first thing you have to do, is you have to allocate the puppy. This does not allocate the puppy. It simply creates the variables, the pointer variables that are going to point to the puppy. So you have to do the new. Now I'm going to copy this for my second puppy, and I'm going to save and build it. And we still have those errors, but whenever you dynamically allocate a variable, you must use the new keyword in C++. So there you go. So, and we still haven't fixed everything yet. Now, when you're dealing with pointers, you don't use the dot nomenclature, you use the dash greater than. And let's see what happens if I save and build that now. And now those errors go away. So I'm just going to say dash greater than, dash greater than. So everywhere I have a dot for puppy, I have to put a dash greater than. I'm going to save and build it. Oh, we still have a problem. I forgot the dash greater than here. This is what I like to call the pointer operator, where it says go into that pointer, dereference it, and grab the data. And now the program runs, or it compiles. Nope, nope, nope. We don't know if it runs yet. Let's go ahead and run it. And it looks like it ran exactly the same way as when we had static puppies. So we took a static puppy program and we converted it, or a static object program, and we converted it to pointers. Really important. Now, but we still have a problem here. And some of you may already know the answer to that problem. I'm going to right click on this, profiling tools, profile with Valgrind. We have some errors. We have some memory errors. Now, it didn't show up in the compile. It didn't show up in the running of the program, but we have some definite problems here. We have basically 144 bytes lost. Now, that's not a big deal, but on Windows, you may never get that 144 bytes back, even when your program ends. And if your program deals with thousands or millions of puppies, which there are in this country, in the United States, you could lose a lot of memory. So we still have to delete the puppies. Now, Valgrind was really great. It showed us that these two are the things that were at fault. So also, I want to show you something else. When I run this, where's my you're deleting a puppy? Where's that from the destructor? If I go over here into the puppy CPP, it never prints you're deleting the puppy. Why? Because we never deleted it. Because they're pointers. The C++ runtime are not going to delete the pointers for you like they did when it was static in the previous video. You have to say delete the puppy. So you can see it doesn't say anywhere here that you're deleting Jack or you're deleting Cassie. So to fix that problem, we're going to go in here and we're going to say delete my first puppy. Then we're going to say delete my second puppy. Let's go ahead and save and build that. Let's run it. And now you can see that we've deleted those. Now also notice that program ending have a nice day is after those deletes, so those destructors are executed before the program ends. And I'm going to right click on this and make absolutely sure, and I'm going to say profiling tools, Valgrind, and we should have 0 problems. There we go, 0 problems. Now, one thing that Valgrind did show us is it showed us that the size of a puppy was 72 because when we didn't delete the puppy, it said you've lost 72 bytes of memory twice. So how can I see? How can I see the size of a puppy? Well, you can simply say cout size of my first puppy. Now, what is that going to display? Some of you probably already know. Well, because my first puppy is no longer a static puppy, is a dynamic puppy, it's going to actually print the size of the puppy pointer, which is 8 bytes. 8 times 8, because a single byte is 8 bits, so 8 times 8 is 64. So that's a 64-bit program. It says that the puppy's only 8 bytes. Well, I thought the teacher here said 72. Well, that's because we're printing the size of the pointer variable. If you actually want to print the size of a puppy, you have to dereference that pointer with the asterisk right in front. And then when I run it, it shows that the size of a puppy is 72. So size of can be used with pointers, but you have to make sure you dereference it first. And we had no Valgrind problems. We had no memory errors because we went ahead and deleted that. Now you can go in and debug this, and these deletes behave exactly like the static puppy delete when the program ends, where it goes into the puppy and it executes the destructor. And you can go ahead and debug that yourself. I would recommend that you do that because it's good practice. All right, so there is our demonstration of object pointers. We're going to be using pointers for the rest, just about for the rest of this series of object-oriented videos. It's very rare that you would see a static object in a program, unless of course it was for like I don't know, a temporary variable, and we might actually do that in some of these videos. But most of the time they're pointers because you would dynamically allocate the memory as you need it. So I hope to see you at our next video on object-oriented programming in C++.